Hello. In this video we're going to continue to build our class hierarchy, which helps us store information about our role-playing game. And in our game you can choose to be a wizard or a barbarian. And the observation we made was that though they both have unique behaviors and attributes, they also have common behaviors and attributes. So in the last video we connected the two classes with a superclass called player and talked about where we would put appropriate fields and methods. And we ended with code that looked slightly different, but the problem was the same. And here's the problem. The problem that has occurred, let's take that out, is that the compiler is telling me this doesn't work. But if I define the reference type as a barbarian, it's perfectly valid. So what's going on here? So just a quick reminder, reference types and object types don't have to be the same. The left side represents your reference type, the right side represents your object type, and they don't have to match. But the rule is that the reference type and object type either have to be of the same class or the reference needs to be a more generic type. So one way to remember that is general to specific. Since player, if we look at our diagram, is a more generic type than barbarian, we can say player something equals new barbarian. Perfectly fine. I cannot write barbarian b equals new player because player is a more generic type. It needs to be general to specific. So here's the really important idea here is at compile time, Java only looks at the reference type. So what happens is when we're compiling this, which is what Eclipse is trying to do right now, is it says, okay, I have a player reference. I'm going to assume that this is a player object. Now, we're smart and we can look and we know that isn't. But that's what Java does. At compile time, Java only looks at the reference type. At runtime, Java evaluates the object type. This is really important. So even though we know this makes sense because the object type is a barbarian, barbarian contains a method called start attack. At compile time, Java just says, wait, you have a player reference, I will assume there's a player object, and player doesn't have a start attack method. So this is where downcasting comes in. So downcasting, often called casting, though downcasting and casting are different, and we'll talk about that in a second. Downcasting is the process of reassuring the compiler that the specified method exists. So essentially it's kind of like me including a little modification to this line that says to the Java compiler, trust me, it's going to be a barbarian. Everything is okay. And we do that by doing this. We downcast by putting the object type in front of the actual variable name, and then we have to put brackets on the outside like this. And this says at compile time, trust me, I know this is going to work, don't worry about it. So I run it, and it works. Now, downcasting is great, but we have to watch because it can cause an error. And let me show you what that is. So I've downcasted B1 to a wizard, which is obviously wrong because the object type is a barbarian. However, the compiler says, okay, great, it's a wizard. So when I run this, it's going to try and invoke the start attack method, and we get a very specific error. We get what's called a class cast exception, meaning that at runtime, Java gets to this line, and it actually evaluates the object type. It says, oh, the object type's a barbarian, and you're trying to make it a wizard? That's a problem. So we have to be particularly careful with downcasting because we can downcast to the wrong class, and that's only going to become a problem at runtime because at runtime Java evaluates the object type and it says, listen, you're trying to make this something that it is not. Okay? So the big ideas to take away from this is that at compile time Java only looks at the reference type. And so when it actually continues to evaluate the rest of the code, it's going to assume that B1 is a player in this case. it's at runtime that Java evaluates the object type. So though putting, and let's get rid of this, though we know that this is perfectly valid because we look at both the reference and the object type when we're coding, Java doesn't know that until runtime, so it won't compile. So that's why we have to do this, to downcast. And again, downcasting, or sometimes called casting, is the process of reassuring the compiler that the specified method exists. I will refer to it as downcasting for the most part. The reason why I don't call it casting is because you've probably already seen casting in a situation like this. Whatever, and then I say int I equals. So that's probably been explained to you to be casting. I'm taking a double and I'm casting it to an integer. The big difference between casting here and downcasting here is that in this case we're actually changing the type of the data. In this example, D is a double and we're actually changing what it looks like. When we cast a double to an integer, we chop off the decimals. Here we're not changing anything. We're just reassuring the compiler that, trust me, I know this is going to work. And on that note, we'll wrap up this video, and as always, if you have any questions, please feel free to ask.